All right, for most calculus students, a problem like this is going to be more of a stretch than your typical derivatives. We're asking you to prove something, and this can be very difficult if you haven't had an analysis or a proofs class prior to taking Calculus 1. So in this case, this is going to be one of the tougher problems you're going to see in 3.4. What I tell you is, we're trying to get from this, the derivative of this, to this. Typically, what we need to do is we need to rewrite this and start down a path. What I will tell you is I know right off the top of my head that secant x is equal to 1 over cos x. So I'm looking for any way that I can rewrite secant x. So if I can rewrite secant x as 1 over cos x, that's where I'm going to start. Now I'm going to do something kind of silly at this point, and I'm actually going to I'm gonna take the derivative of 1 over cos x. So I want to figure out what d dx of 1 over cos x is. And I'm going to treat it like it's a quotient rule. So if you remember the quotient rule would say that we're gonna take g of x times f prime of x. We're going to subtract out f of x times g prime of x. And we're going to put all of that over gx squared. Oh, sorry about that. Sometimes when I get to the edge here, it can be hard to get a good read there. All right, pen. All right, all over gx squared. So this is what I'm going to use to kind of solve this. And I'm just going to pretend that this is a normal function, f over g, and it's a quotient rule. So I'm going to say that the I'll just call this f prime of x or whatever right now. And I'm going to say, well, what's g of x? Well, g of x is cos x. We know that. Looking up at the top here, the g term is cos x. Well, f prime of x. Well, what's the derivative of 1? Well, the derivative of 1 is 0. And then we got to subtract f of x, which is 1, multiplied by g prime of x. Well, cos x derivative is negative sine x. I feel like we're doing pretty good there. We'll put all of that over gx squared, which is going to be cos squared x. So I feel like we've got something that kind of works right now, and I want to kind of see if this simplifies it all. Well, cos x times 0 just becomes 0. This whole term goes to 0, and negative 1 times negative sine x is just sine x. So in this case, this is equal to sine x over cos squared x. Cos squared x. And now you might say, well, I wonder what else I can write this as. It looks like we're close, but we're definitely not this. This is our goal. We can't stop until we've gotten to those two terms. So I can say, you know what? I can rewrite sine x over cos x. So I can say f prime of x is still sine x over cos x. But this time, I'm going to say it's 1 over cos x times sine x over cos x. And what that gives me now is 1 times sine x is sine x over cos x is cos squared x. Now remember back what we said earlier here was that secant x was equal to 1 over cos x. So isn't it true then that I can write 1 over cos x as secant x? And if you look back to the definition of tangent x is sine x over cos x. So look in the front mat of your textbook there. And what you'll find now is you've found out that f prime of x is secant x tan x. And usually when we do that, we put this nice little square here that basically says our proof is complete. Or we might say QED. Don't remember what it stands for, but it's Latin for that which was to be proven or something like that. So either one of these basically say I'm done. So that's 3.4, number 24.